Hello and welcome back to our subject, digital signal processing. Now, last meeting, we discussed the block diagram of a digital signal processing system. And today, we will be focusing more on the two areas of that particular block diagram, which is the transducer and the sample and hold circuit. So, let us define first what is a transducer. A transducer is an electronic device that converts energy from one form to another. That is our definition of a transducer. Meaning to say, it is an electronic device that converts a particular energy, let's say sound energy, into an electrical energy, or vice versa. No? We can also have an electrical energy which can be converted into the sound or an audio. Or another one is a transducer that converts uh, temperature into electrical signal, or a pressure into electrical signal. No, so that's an example of a transducer. Now, in our discussion, we will focus on the audio or sound transducers. No? So, in the audio or sound transducers, there are two types. One is the input sensors, or sound to electrical transducers, and output actuators, or electrical to sound transducers. The example of input sensor is a microphone. So that's a transducer which converts sound into electrical. And for output actuator, an example of which is your loudspeaker, which converts an electrical signal into a sound or an audio. Now, sound transducers can detect and transmit sound waves. If the frequency of the sound wave is very low, then they are called infrasound. Okay, so again, if the sound wave is very low, then they are called the infrasound. And if the frequency of sound wave is very high, then it is called the ultrasound. Okay, so these are the two types of uh, audio or sound transducers. No? One again is the input sensors or sound to electrical transducer, and the other one is the output actuators or electrical to sound transducers. All right. Okay. So in figure 1 here, we have a microphone. So how does a microphone converts a sound wave into an electrical signal? So these are the parts of your microphone. Okay. So this area here is your diaphragm. And this area here is your magnet. Okay. And attached on the magnet is your moving coil. This one. Okay. So how does, again, microphone converts sound wave into electrical signal? So when you speak in front of the microphone, the diaphragm here will move, right? Now, the movement of the diaphragm causes your moving coil here to move also. Now, since there is magnet, then the movement of the coil will produce electric current. Okay? That is according to Faraday's law of induction, which describes how an electric current produces a magnetic field, and conversely, how changing magnetic field generates an electric current in a conductor. Okay, so that's how a microphone as a transducer converts a sound wave into electric circuit or electric current, I mean. Okay, so we're done with transducer. We go now to sample and hold circuit. So this is the block diagram that we discussed last meeting. The block diagram is called the digital signal processing system block diagram. Okay, so what we discussed earlier is the transducer, which is this one here. And one example of the transducer that we use is the microphone. So we go now to sample and hold circuit, this one here, this block diagram. So let us define first what is sample and hold circuit. Sample and hold circuit are used to sample an analog signal at a particular instant and hold the value of the sample as long as required. That is our definition of sample and hold circuit. Okay? Okay. So what we have here in figure 3 is a block diagram of a sample and hold circuit. Okay? Now, in this area here, we have signal to be sampled. The signal to be sampled here comes from your transducer, which is in this case the microphone. And this signal will be inputted here in your V input. Okay? Now, what does the sample and hold circuit do? For a particular part of your input signal, it will be sampled by the sample and hold circuit. For example, this one here, this area, okay? Magkuha siya sample. And then this sample will be held for a very short period of time. Magdepende na siya sa tuang circuit. Okay? And this signal or sampled signal will be transmitted towards your output area of your sample and hold circuit. And we call it the sampled value holded. Okay? And this particular sample value will now be transmitted towards your analog to digital converter. Okay? So again, it will take another sample. Say for example, this particular area here. A sample taken again from your signal to be sampled from your transducer. And this particular signal will be held again for a very short period of time and will be transmitted towards your analog to digital converter. So again, we have here a clearer vision on how the sample and hold circuit functions, no? So input and output waveforms of a typical sample and hold circuit. So for example, this is our signal taken from our transducer. Now, this signal here will be sampled once it passes through a sample and hold circuit. Okay, so for this particular area, for example, it will be sampled here, and that will be this particular node here is the sample of this particular signal. And this one here is the sample of this particular area of your signal, and so on. Okay, so this one here is what we call the sampled input coming from your analog input, which was produced by your transducer. Then, we have here the analog hold inputs. So once your signal is being sampled here, which is this one here, now this signal will be held for a short period of time here, then transmitted into your analog to digital converter, and then it will sample again. This one here, it will be sampled again, which is in this particular area, this node here, and then it will be held again for a period of time, and then it will take again another sample. Now this analog hold inputs will be transmitted towards your analog to digital converter. So what we have here is a simple sample and hold circuit. It uses the principle of RC circuit. It contains your source VA, which is the source coming from your transducer, in this case, this particular signal here. We have here a switch and a capacitor. We know that the capacitor charges and discharges. Now, there are two conditions of the switch. We have an open switch, which means it holds the data, and we have closed condition of the switch, which means it takes a sample of the data or the signal. Okay, so let's say we close the switch in this particular period of time here. We close the switch. So when the switch is closed, automatically, for example, in this particular area here, we close the switch. So this value of your signal will be charged into your capacitor. No? So it is shown here in our diagram. If the switch is closed, this particular data here will be charged into your capacitor. And when you open the switch, this one here, when you open the switch, what does it mean? It holds the data. So, for a period of time, this data here, which is being charged in your capacitor, will be held for a certain period of time. And this data will be transmitted into your output VO and going as input to your analog to digital converter or ADC. Now, if you close again the switch in this particular area here of your signal, then again it will sample that particular signal. Meaning to say that this signal here will be charged again into your capacitor. And when you open again the switch, it will held, the signal will be held for a certain period of time, no? And as we know, the capacitor here will discharge, and the discharge value of your capacitor will be going towards the input area of your analog to digital converter. Now, when you close again the switch in this particular signal here, then it will again take a sample of that particular signal, and then it will be charged again into your capacitor. And when you open the switch, it will be held for a certain period of time. And at that particular time also, that signal which will be discharged by your capacitor will be going towards your analog to digital converter.